Welcome to our Nano Innovation channel and our Nano Innovation Laboratory. So this is Professor Subhankar and today we are going to talk about our new innovation that is called, we call it green cement, and also you can say it's a green mortar. Like the difference between the cement and mortar is the cement is the material which is used and for construction purpose, and the mortar means like when it mixed with the sands. Normally we call it mortars because once you, these are the aggregates, sands are the aggregates because they actually can accumulate or aggregate among themselves. This is the way they are basically giving a strength of the materials when it becomes a concrete. So these typical cements are available in the market and they are called Portland cements. In normally commercially available cements, they are called Portland cements. But this time we have innovated a new kind of cements. We call it a green cement because there's no such Portland cement or commercial cement in it. Now, before I going into that, I just want to introduce you about the cements. Cement is basically coming from the calcium carbonate, so it's mined and then it is mixed with the dust, a lot of other compositions, and they are produced. When CaCO3 or this limestone is actually is converted into CaO, then it is basically thermally heated. So during this heating process, lot of carbon dioxide is produced, and this is what is approximately 8% of the total carbon dioxide produced by various factories or by globally. So if you can, our innovations from that this point of view is very important because if you can start using green cement in place of this commercial cement, then actually we can not only reduce the carbon footprint, but at the same times we can save a lot of such calcium carbonate which are mined continuously and can reduce our cost. Now this green cement that we have developed is basically derived from the fly ash, coal fly ash more specifically, because it is a waste. It is a waste. It is a waste, and the waste is derived coming from the thermal power plant. And thermal power plant, like they fire the coal and they generate heats and then using the boilers, and they actually generate electricity. During this process, a lot of like the fly ash is called fly ash. So ash is produced from the coal. So this fly ash is basically precipitated by electroprecipitators in various thermal power plants, and these are huge amounts. So this is the waste which are dumped here and there. Now, as per the government policies, these are the materials are used for the bricks, for making bricks and construction, other construction materials. However, so we are not using these fly ash directly. We are using this fly ash and we are chemically converting them a different kind of more pozzolanic materials like cementitious materials. These cementitious materials basically can stick, can have the power to become solid very quickly. They have the self-sticky powers, and also we have modified our aggregates sands, and these aggregates also when these aggregates are mixed with our green cements, it becomes green mortar. So I will show you the samples of the cement, green cement, and the green aggregates. So if you mix them, we call them green mortar. Let's go there. Okay, so as I told you, I want to show you our green cement. So this is our green cement. So what is derived from the fly ash. So this is unique and uniquely processed. This is very important because the processing time, processing conditions, etc., etc. This made it this unique. This is we call them green cement, and this is what is the aggregates or typical. This aggregate is very important because unless this aggregates is mixed with that, we don't call it a green mortar. So when you mix with that, so if you mix this with this, basically when you mix both of them with a typical stoichiometry, weight by weight ratio, and along with some other kind of solutions, then we call them the green mortars. So the green mortars are very effective
as we'll show you in the outdoors. We have already made some kinds of samples, constructed some brick walls. We have already fixed with some kind of big granite tiles with the walls, and how they are behaving, working, that will show. Before that, I want to show you that this fly ash, this is to be called coal fly ash, CFA. This is coming from the any thermal power plant. When they fire after firing the coal is burnt, and after that this ash is produced, is called coal fly ash. This innovation is one of the best innovations so far we have made from our laboratory, and we have already filed the patents for this innovative work. And I want to also introduce our student who has done this work, my PhD student, Mr. Ashutosh Kumar Singh. Please come. So he's my PhD scholar, Mr. Ashutosh Kumar Singh. He has implemented all this work, like the optimizations and the unique processing of this fly ash into these pozzolanic materials that we call green cements, and then a lot of modifications of the sands or the new aggregates, or you can also can say that the aggregates, modified aggregates. And this modified aggregates is the unique because its properties also is important when mixed with our green cements to make it a green mortar. And when you add the solutions, it becomes paste, like when we add the simple normal normally that available market available the Portland cements and water and sand. So the process is same. A technique is little bit differently. We make the paste, and that unique technique also is important if you get the effective and a better result, like mechanical strength and the duration, that is the curing time, the solidification time, and of course the strength of the compressive strength and etc. other things, and of course the resistance power, that means the its resistance against the corrosions, like when there's a weather change, rapid change of temperatures, like when the daytime is 40 and the night time is as low as 10 degree, like that happens in desert, where this temperature change can bring a crack in the in this kind of concrete very quickly. That doesn't happen. Also, another important part is that it holds a lot of moisture, so you don't require to add water. In contrary to that, what we do in the typical plastering or concrete preparations using our normal Portland cements and sands, the concrete. So that concrete, we when we make it and we build it, any constructions, we require a lot of water. So for continuously at least for 7 days to 14 days, and if you can keep on giving for another 21 days is good. Anyway, so this is our new innovative things, and I thank Mr. Ashutosh Kumar Singh for doing such a great job. Thank you, Ashutosh. So this is our, we have got our green cement and the green mortars. So we have set up a small brick wall using that. We have two walls. One is for the Portland cement based, where Portland cement is mixed with the sands, and 1:3 ratios, and we made this, build this small wall kind of things. This is another sample which is testing test samples, our samples, and for this case we have used our own green cements and our own modified aggregates. So you can see the green mortars, and then we also so 1:3 ratio we have also used here, 1:3 ratio we have used there also. That is commercial cement. These are own innovative green cements that we have produced in our laboratories. Now, the one good thing that we have observed is that when we started working on this, we found that it got its strength, achieved it very quickly, almost as half of the time of that one. So approximately within 180 minutes, it completely got hard. So look at the strength; it's very strong. I'll show you how strong this is, made of our green cement. based this and using our bricks we have made this wall. So I will show you how strong this is and how strong that one. So that is commercial made, and this is our innovative green cement paste. Okay, I'll show you that I'm standing here, I'm jumping on this. Okay, good balance, and then I'm down, jumping down. Again, I'm going up and going down, going up and going down. Nothing is happening. Uh, let's see for that one also. So if I do like that and see, this is the thing, under the same conditions we have made this moving. So I'm a bit afraid on jumping up and jumping down because it may fall like this. However, it is strong, strongly built. Under the same conditions, this was built, but this is not moving at all. Even probably two men can stand and two men can jump on this, nothing will happen. So this proves that our innovative green cement is really working fine and got much strength than that one. You can see 86 kilo, right? 87 kilo. So it's too bulky. It looks like bulky. So 86 kilo standing on it, and please jump out of this. And again, you try to quickly jump on it. It's nothing happening. You see how strong this is. Even if I do like this, nothing is happening. Do like nothing is happening. See, I'm even standing. Okay, along with him. So 86. I'm not very bulky. I'm only 60 kilos. So 60 plus 87, 147, right? Approximately 147 kilos. We are jumping. We are standing on it, nothing is happening. That proves that. However, I'm afraid because once I put like this, you can see this is moving. So under the same conditions, we build both of them, the same ratio, same composition, same stoichiometry, but there's green cement, which is cementless, Portland cementless. We made it from the fly ash based, but some kind of treatment we have done, and then we made this. We built from this common sand and the cement, Portland cement, commercial cement. Proves that it is very strong. So this kind of this is our one of the examples, and we have also experienced good strength. That proves that our innovations is going to be working in the real field. So on the other hand, if you look at this is another one. This is one. This is one, the commercial one. So this is our green one. Okay. So the commercial one, it has little bit movement. You can see uh, under the same conditions we made, but there is no movement as such here. So that proves that God's much higher strength than this one. So let's go to some other examples. I'll show you some other kind of our constructions based on these green cements. Let's go. So again, I've come outdoor. Now I'll show you some more examples that are real applications of our green cement and green mortar. In this case, you can look at this, some marked there granite tiles, almost 5 feet long and almost 1 foot a little more the breadth and thick one. So this is where it was to be pasted and fixed it. So in this case, 3 such cases we have done and taken as our case studies, and we have used our this mortar, green cement plus our aggregates that we have innovated in our laboratory, and then we have pasted this this granite tiles onto that, and it is already done 2 months back, and in between there is rain also, and the temperature has changed a lot. Now it is a winter time, so when you did it, the temperature was not so low. So a drastic environmental conditions has undergone, and this still looks nicely fixed on it. So I'm doing like this. I'm also uh, people can do like that. It got lot of strength. Okay, so it got lot of strength. So this is the one of the examples just we have seen earlier, where we have made it the a small brick walls, because that was a different kind of examples, because that mostly requires how strongly they can fix on the soil, and this is just when we fix it with this, It has its own weight, and weight is quite heavy. You can understand if it is a almost 1 inch thick and the 5 feet long and more than almost 1 feet, probably 1 feet, a little more is the breadth, then that granite tiles would be quite heavy, and keeping it fixed is very difficult. I show you some examples where it was fixed probably 1 year back, but however it has opened. It has been removed because of the weather conditions. That means that there is a normal cements not properly pasted probably, or whatever the reasons, but this has been done by us, our innovative green cements and green mortars, and nicely fixed. So these are another examples. You can see that we have found this is not properly fixed. This is also is removed already. So we thought that let's see to fix using our green cement, green mortar, whether it can be fixed properly or not. So we have done like this similar way. We have removed first and clean this space, and then after cleaning we allow to dry it, sun dry, and then after that we put our paste. Our paste means our green cement and green mortar mixed with our solutions and pasted that. And then after that, once the paste has been spread over and little bit engineering leveling we have done, after that we have cleaned this also. See the other sides, it's a lot of soils are there sticked on that, so we have also cleaned that one earlier, and then dried. After that we fixed onto that. So once we fixed, so it is almost 20 days is over, or little maybe 22 or more than 22 days, and see the it is so strong now. I cannot even, I'm pushing hard but it is not coming out. Okay, so this is the testing using our green cement. On the other hand, you see it is opening very easily. So this was done probably, and not mostly not done using such kind of thing. So this is our innovations. So this again, you can see the green cement is there in the bottom of this. It is still can be seen by you, the green cements. This is one of the good qualities, is that this green cement not only working as the cement just like the cement that we use or available in the market, but this green cement, which is basically the typical commercial cement free, and we have derived from the fly ash. So this is one kind of waste from the thermal power plant. Say when the coal is fired, after that the fly ash is produced. So this one also can absorb the carbon dioxides and such kind of the gases, which are also the one of the cause of the global warming, and gradually from the environment. So if it can use continuously this green cements for the constructions and various road constructions and building constructions and other purposes, so this can not only can give you a better strength and a reductions of carbon footprint that we are getting, that normally it is caused by the various cement industries, but also it can absorb some more amount of carbon dioxide from the environments, so far that we have come to know. But it can also absorb some other kind of pollutants that we are still working on that. So this is one of the good aspects of our innovation. Thank you.